Come back to the DellyMaths concept. What we're looking at today is a geometry fun question, one in which we're required to find the area of this shaded region. So we want to find the area of this and this combined. All right. One of the first things that we want to do is to establish what we have. So we have some squares. So this is one square. This is another square. This is another square. This is another square. And there is a triangle here. And the fact that we have squares, we're looking at some right angles. So I could quickly label this as a right angle that I'll be using to help me. All right, so let us start off by labeling as much as we can. So I'm going to label this side of the square here. All right, so I'm going to call it, let us say I call this X. So let us say I call this X. So this is X X units long. And then this part of the square, this side of the triangle, I'm going to call that Y. So let's say we call that part Y. So this is Y. So I'm calling that Y. What it means is that this side here is also X because it's a square. This is X. This is also X. And then this part of this smaller square here, one side of this smaller square would actually be, it will actually be X minus Y. And what we're looking at is it's going to be X, which is all of this distance here. And then we're going to have to subtract this length. So it's going to be X minus Y for that. So what it means here is this is X minus Y as well. And if we want to put it going around X minus Y, also X minus Y. All right. As for the larger square, or here, this the largest square here, this side, it's going to be a combination of X and Y. So we're looking at X for this part plus Y. So the entire length is going to be X plus Y, which means that this is also X plus Y. With this, we could go forward. I'm going to go forward with one of the most important part of this question, which is this 4 that we got, which is the hypotenuse side of that right triangle. So let's utilize this right triangle right here in an effort to help us to have some base idea that we would be utilizing as we go. So let us take a look. It is said that the two shorter sides, so I'm looking at the triangle, so I'm putting the triangle here. So in utilizing this triangle, I could say that X squared plus Y squared will give us 4 squared. And we're talking about using the Pythagorean theorem where the two shorter sides square, if you add them, it's going to be equal to the hypotenuse square, which is, so basically this is saying that X squared plus Y squared gives us 16. And we want to hold that close to us. What we also want to do is to find an expression for the ideas that we need. What do I mean? I'm going to find an expression for, let us say I call this a square 1, which is a small square, and square 2, the larger of the two. So based on the fact that we have the sides, I could find their area in terms of X and Y. So firstly, I'm finding the area of square 1, right? And I'm expressing the idea. So the area of square 1 will be X minus Y all square. And remember, it is a square. So the sides are equal. So what does this mean? It really means that we're going to have X minus Y times X minus Y. And then we could FOIL this out, So x will go with the x, and then x will go with the negative y, then negative y with the x, and then negative y with negative y. So let us write out what we got. When x goes with x, we're going to get x squared. When x goes with negative y, we're going to get negative xy. When negative y goes with x, we're going to get negative xy again. And negative y times negative y would have given us positive y squared. If we finalize this, we're having x squared minus 2xy plus y squared. So that is a sort of the expression for the area of that first and smallest part of the shaded area that we. Let us take a trip in terms of finding the area of the larger square, and I'm calling it square 2. Square 2 is represented by the side x plus y. So let us put this down, x plus y. So x plus y squared, because the length of the square would be the same. So x plus y times x plus y. So we're looking at x plus y, and this is used to multiply by x plus y. And we're going to file this out just the same. So x will multiply to x, and then x will multiply to y, then the y will go with the x, and then the y will go with the y. So let us simplify this idea. When x multiplied by x, I'm going to get x squared. When x times y will give me xy, y times x will give me xy, and then y times y will give me y raised to the second power. Now, let us simplify this. We're looking at x squared plus 2xy plus y squared. So there it is. I actually have the area of the largest square that we need being expressed in terms of x and y. Now, let's put the idea together. So what we're doing here, we're talking about adding the area of the two shaded region that we have. So we're looking at adding the area of square 1 and 2. So we're going to put them together. So we're talking about having x squared minus 2xy plus y squared. And we're adding that to x squared plus 2xy plus y squared. So if we should put everything together, we're going to get 2x squared. And this negative and positive becomes 0 plus 2y squared. If I should factor out the 2, I'm going to have 2 times x squared plus y squared. So that's the area that I really want, all right? So the shaded region, so remember now, this is actually the shaded region that we just put together in terms of x and y. That's the shaded region. Now, if we go back to the beginning, right here, when we utilize a triangle, x squared plus y squared is 16. So right here, we could actually put that in. We could substitute x squared plus y squared because it is 16. So we're going to have 16 here being substituting for x squared plus y squared. So I'm getting 32 square units. So this is my shaded area. So the shaded area is actually equal to 32 square units. See you next time when we work out some more problems and DellyMaths concepts. Bye-bye.